Out in the world, this happens all the time. Chemicals get mixed, but not in stoichiometric proportions. They get mixed in random proportions, right? Substances squeezing into each other in the Earth's mantle, or people mixing chemicals by sloshing them together, or your body, where things are not pre-measured. This is perhaps the most common scenario. And so let's take a good look at limiting and excess reactants. Once again, we're dealing with the burning of butane, just to stay on the same page. And the question says, we're burning 100 grams of butane, but this time we only have a specific amount, and it's the same amount, 100 grams of oxygen. How many grams of carbon dioxide will it produce? There's two ways to do this, the systematic way and the fast way. The fast way is a little harder to see, but I'm going to go ahead and explain it to you. I just take molar amounts and see which one I don't have enough of. As written, since 58 grams is a mole, it requires 116 grams on a molar scale, but 13 times 32, that's a lot more than 116. I don't have enough oxygen. It is my limiting reactant. Everything will stop as soon as the oxygen runs out, so I would perform a three-step calculation based on oxygen alone, and that'll solve the problem. If you understand that, fine. But the initial method that's recommended is just take each one of these, see how much it produces. The lower one is the one you ran out of first. That reactant's gone, and the reaction comes to a screeching halt. So let's do the 100 grams of butane first. If you've watched the prior screencasts, you know that gram-to-gram conversions are three-steppers. So we go ahead and write the three-step conversion. And by the way, this is the logic that we used to determine the limiting reactant in our head. Let's just read it. 116 grams of butane needs 13 times 32 grams of oxygen. That's more than 300 grams. We don't have enough oxygen. It's the limiting reactant. But here's the longer but reliable method. We're going to see how far the butane takes us. Well, 58 grams is a mole, but every mole of butane will make 4 times as many moles of carbon dioxide, which in turn weighs 44 grams. I did that really quickly because if you watch the previous screencasts, it's been done nice and slow. Well, we got enough butane to take us through 303 grams of carbon dioxide. I think we don't have enough oxygen. Let's see if it's true. That 100 grams of oxygen weighs 32 grams per mole. Each mole of oxygen will only make less. 13 makes 8. So 8/13 is times as many moles of carbon dioxide, which still weighs 44 grams. And we only have enough oxygen to make 85 grams. We're done. This reaction will make 85 grams of carbon dioxide, which begs the question, how much of the butane is left over, right? If we have some excess, not all of it burnt, I wonder how much is left over. The logic for this is, oh, and there it is. The limiting reactant is oxygen. We've figured that out. The excess reactant is butane. How much remains? Why don't we figure out how much got consumed by that oxygen? Now, listen to that carefully, because that means we are going to do a three-step conversion from the grams of oxygen, which got totally consumed, to the grams of butane, which it reacted with. The rest is excess. Listen to that again if you need to, because that's the logic for determining excess. And here it is written out. It's easy. Find out how much was needed. So we know a certain amount was consumed. The rest will be excess. 100 grams of oxygen, we're going to go to grams of butane. We can do that. We can seemingly go from grams to anything. So 32 grams of oxygen is our mole. But this time, let's go from moles of oxygen to moles of butane. Where is it? Oxygen to butane. 13 only requires 2. And there it is. And those moles of butane weigh 58 grams each. And everything should cancel, and it's a good idea to make sure it does. Boom, 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 and we're good. Punch it all in, and don't think that you have the answer, because this was how much it got burned up. 27.89 grams of butane are gone from your Bic lighter, but 72.11 grams remains, and that's what they asked. That's the answer to the question. This is limiting and excess reactants.